This is an A2Pure video on the product rule and the quotient rule for differentiation. So if you have a function uv, as in it's in two different parts where u and v are both functions of x, and dy by dx equals u dv by dx plus v du by dx. The first example is we have to differentiate y equals x squared upon 1 plus x to the power 4. Now this wouldn't be a classic example of the product rule. You could do it different ways by multiplying the whole thing out. But hopefully you can see that we know how to differentiate this. Also using the chain rule we now know how to differentiate this. But because they're multiplied by each other, we can't just differentiate this and differentiate this. It's not going to give the right solution. It's not going to give the gradient function. So what we want to do is to see the two parts. We let u equal x squared. We let v equal 1 plus x to the power 4. And we work out du by dx, so differentiating this, we're going to get 2x. We work out dv by dx, so how's this one going to work out? Using our chain rule, we bring the 4 to the front. If we differentiate the bracket, we just get a 1 anyway, so that doesn't affect the 4. 1 plus x cubed. The formula we're going to use then, dy by dx equals u dv by dx plus v du by dx. Substituting in, u is x squared, dv by dx, so we're multiplying that then by 4 upon 1 plus x cubed, plus v du by dx, so 1 plus x all to the power 4 multiplied then by 2x. So let's start to tidy some stuff up here and see how we get on. So it's going to be 4x squared upon 1 plus x cubed plus 2x upon 1 plus x all to the power 4. Now to be honest, I would probably give you full marks for that. In terms of working out our product rule, that's totally fine, but people tend to then factorize these things out, and this is the bit where people actually mess up. They can do the other bit fine, but this is the bit that's a wee bit tough. So there's a common 2 we can take out, there's a common x we can take out, and there's a common 1 plus x cubed. Let's just take this nice and slowly. I'm going to put the other bits in a big square bracket. So 2x times what gives me 4x squared? It's going to be 2x. 1 plus x cubed times what gives me 1 plus x cubed? That's all fine. 2x times what? That's going to be nothing. That's fine. And then 1 plus x cubed, 1 plus x, so it's then going to be a 1 plus x there. So our final answer, then if we finally tidy up, is 2x upon 1 plus x cubed upon 3x plus 1. As I said, I would give full marks for this. To be honest, we're practicing using the product rule here, so that's the bit that I want to see most of all. Let's look at example 2. Hopefully you can see it. Again, this is going to be our u, this is going to be our v. Let's get this set up here so I know what I'm doing. I'm going to let u equal to 3x cubed. I'm going to let v equal 2x minus 5 all to the power 4. du by dx is of course going to be 9x squared. dv by dx, I'm going to do this in 2 lines. So what do? I bring the 4, 2x minus 5, that's all then to the power 3, and I'm going to multiply that then by the bracket differentiated. And so that is then going to be 2, so that's actually 8 upon 2x minus 5 all cubed. Working out dy by dx then, it's a bit of a palaver here, but we'll be up for that. dy by dx is going to be, get this right, sorry, u dv by dx plus v du by dx. And I tend to just, I always use the same layout every time. So over to the right hand side, u and v, du by dx, dv by dx, and it just keeps things, everything nice and neat. So u, where is u? 3x cubed multiplied by 2x minus, sorry, yeah, where are we? multiplied by 8. What a mess. 8 upon 2x minus 5 all cubed plus v 2x minus 5 all to the power 4 multiplied by 9x squared. Let's start to tidy things up. 3x cubed times 8, so that's 24x cubed 2x minus 5 cubed plus 9x squared upon 2x minus 5 all to the power 4. Again, just to annoy you all, let's factorize it out. So biggest factor I can take out of 24 and 9 is 3. Biggest factor I can take out of x cubed and x squared is x squared. And then we're going to take the 2x minus 5 all to the power 3. Big square bracket. This times what gives me this? That's going to be 8x. This times what gives me this? It's going to be 3. And there's a 2x minus 5 because it's only the power 3. And we need them to the power 4. So final line, 3x squared upon 2x minus 5 cubed. And then tidying all this up, that's an 8x and that's a 6x. So that's going to be a 14x take away 15. So that's our product rule. On then to the quotient rule, which I hope you can kind of guess what's going to be going on here. Straightforward enough. So if y equals u over v, where u and v are both functions of x, then dy by dx is v du by dx minus u du by dx all over v squared. It's straightforward enough. It just looks a bit complicated. And so here's the case. We're going to let u equal 2x. Now we'll have to do it that way around this time. For the previous one, for the product rule, you didn't. You could pick and choose your u and your v. Not that it makes any difference. Our v is then going to be x squared take away 2. du by dx is 2. dv by dx is 2x. And then let's use our formula. So as it says above, dy by dx equals v du by dx minus u dv by dx all over v squared. Start subbing in. Won't do anything too fancy. X squared take away 2 multiplied by du by dx, which is 2. I don't know if you've seen these wee dots here, they use as multiplied. Take away u dv by dx, so that's just 2x times 2x. And then that's all over v squared, so that's x squared minus 2 all squared. So how does this tidy up? Top line, we're going to have 2x squared minus 4 take away 4x squared. Isn't that right? That's all over x squared minus 2 all squared. 2x squared, why is it not here? 2x squared take away 4x squared and then kind of minus 4. So that's just going to give us minus 2. Make sure you can see this. Minus 2 x squared minus 4 all over x squared minus 2 all squared. We're probably feeling that tidies up a bit further. No, it's not going to. That's our final answer there. Last example then. It's a bit of a messy looking one, but we should get there okay. U is going to be 2x minus 3 cubed. Maybe leave myself a little bit more space here, but we'll make it work. 3x plus 1 all cubed. Du by dx. We'll just do this in one line. We'll be able to take the 3 is going to come to the front, but you multiply by the bracket differentiated, so it's going to be a 6 upon 2x minus 3. Take 1 away from the power, it's going to be squared. dv by dx is similar. The 3 is going to come to the front, but multiplied by the bracket differentiated. That's going to be 9 upon 3x plus 1 all squared. So here goes. Dy by dx equals v du by dx minus u dv by dx all over v squared. V, where did v go? 3x plus 1 all cubed. du by dx. 6 upon 2x minus 3 all squared. Take away u. 2x minus 3 cubed. dv by dx. 9 upon 3x plus 1 all squared. That is all going to be over v squared, so that's going to be then 3x plus 1 all to the power of 6 because it was already cubed. I hope that makes a little bit of sense for you. We could cancel some stuff here, but isn't it always more fun to factorize at the start? So let's see. Just the top line we're going to factorize here. We have a 3x plus 1 to the 3. In fact, first of all, we have a 6 in this term. This is all the one term. We have a 9 in this term. So we're going to take out a 3. With a 3x plus 1 cubed, we have a 3x plus 1 squared, so we can take out a 3x plus 1 squared. We have a 2x minus 3 squared, a 2x minus 3 cubed. So we take out a 2x minus 3 all squared. 3 times, so that's going to be 2 upon 3x plus 1. Take away 3 upon 2x minus 3. I hope you're still with me. And that's all over then 3x plus 1 all to the power of 6. We are nearly there. Inside this bracket ties up very nicely. That's a 6x there, and that's a minus 6x, so that disappears. That's a 2, and then a minus 9. So inside this bracket actually just becomes an 11. So 11 times the 3 here is going to give us a 33 out the front. We'll not do that quite yet. And then the 3x plus 1 to the 6 and a 3x plus 1 squared, we can change that to a 4 and get rid of that. So we're going to go 3 upon 2x minus 3 squared upon 11, which is our big bracket, all over 3x plus 1 all to the power 4, and then just finally 33 2x minus 3 all squared all over 3x plus 1 to the power 4. I hope you get the idea of the quotient rule. This is the important bit here. Let's not worry too much and get ourselves too confused about some of the ropey algebra there, but that's what we end up with.